Alright guys, we're going with video notes for today. Because it's going to make things a little bit easier. You can go back and rewatch any part that you need to. And it's easier for me to write on this than trying to do that online whiteboard while you guys are all zooming in. Okay, so here we go. Today we're going to be looking at VSEPR structures, okay, which is a way that electrons are shaped and how they help shape molecules based on the fact that like charges repel. Okay, so remember, electrons have a negative charge. They are repelling one another because they have like charges. They want to get as far away from one another as possible. All right, so we're going to do 4 examples here. The first one we're starting with is CH4. So I want you to take a moment and across your notes, go ahead and make the table here that says molecule, and then write your 4 molecules underneath it. Give yourself some space, you're going to need it. And then Lewis structure, VSEPR structure, that's VSEPR structure, the VSEPR name, and the polarity. So those are the categories that we're going to be looking at today. All right, so let's start with CH4. Remember that you can pause this at any time because it is a video, so if you need a minute, pause it, take a minute. Okay, so let's start with the Lewis structure. We know that carbon wants to get to 8 and hydrogen wants to get to 2 valence electrons. So carbon here is going in the center, and then we have 4 hydrogens, 1, 2, 3, 4. Okay, so then our VSEPR structure, again, is how the atoms are going to be arranged in the molecule based on wanting to be as far apart as possible. Okay, so carbon still stays in the middle, and we have our 1 hydrogen up at the top because it has a lot of space up there by itself. Okay, so then everything else kind of gets pushed down so that there's enough space for everybody to spread out. So 1 hydrogen comes over here off to the side. Do you see how there's a bigger space here now between these 2 hydrogens than there was here? Okay. Then we're going to have 1 that's going to be like coming out of the page towards you, out in front of the carbon. The way to show that is to draw a little triangle here that indicates that this part is kind of farther back and the larger part is coming towards you. Okay, and then we put a hydrogen here, and then another hydrogen, our last hydrogen, is going to be like going back into the page. And to show that it's going behind the carbon here, we're going to use a dotted line, which tells us it's going backwards. Okay, so it's kind of a 3D shape here. The name for this type of VSEPR molecule is tetrahedral. Because we have 4 things around a center molecule. And then for polarity, we're looking to see if the molecule has any partial charges. So we're going to start by drawing our VSEPR structure again. And then you're going to look at your periodic table, and you're going to compare the electronegativities of the elements in the compound. All right, so we're going to look at carbon and we're going to look at hydrogen. Hydrogen is at the far left of the periodic table, which tells us that it has a low electronegativity. Carbon is closer to the right, so it has a higher electronegativity. So you're going to come to each bond here, and you're going to draw an arrow following that bond towards the one that is more electronegative. That's telling us that the electrons are moving towards that one. Then you're going to put a little plus sign at the tail, reminding you that because the electrons are moving towards the other way, this part is becoming partially positive. Okay, so we look at all sides of the molecule. We see that it's positive at this hydrogen, at this hydrogen, at this hydrogen, and at this hydrogen. All the sides are the same. They all have that slightly positive tail. around the outside. So that tells us that it is non-polar. All right, let's take a look at number 2. Ammonia, or NH3. Okay, so we have nitrogen, which has 5 valence electrons, and again hydrogen, which each have 1. So we're going to put 1 hydrogen here, 1 hydrogen here, and 1 hydrogen here to complete our octet for nitrogen, and so that hydrogen each have 2. We're going to show our non-bonding pair here up at the top. All right. It's important to remember that our non-bonding pair up here, sorry guys, this non-bonding pair right here of electrons takes up more space than a pair of electrons that are shared between atoms. Because they're not being shared, they have room to spread out. Okay, so these non-bonding electrons are taking up more space. Because of that, they push everything else down to try to take up as much space as they possibly can. Okay, so we put nitrogen here still at the center, and we put our non-bonding pair here. To show that the electrons are taking up space, we put a little bubble around them. Okay, so that's showing that those electrons are taking up a lot of space. And they're going to push everything else, all these other hydrogens, down and out of the way. So again, we're going to show that 1 hydrogen comes out to the side. 1 is coming towards us. And 1 is going back into the page. The name for this VSEPR model, where there's a non-bonding pair at the top and 3 bonded pairs at the bottom, is trigonal pyramidal. Trigonal for 3, like a triangle. Pyramidal because they're all spreading out. All right, and then for polarity, we are going to redraw our VSEPR structure. And then we're going to use our periodic table again to look for polarity. I'm sorry, for electronegativity, to help us determine the polarity. So we look at nitrogen on the periodic table. You see it's towards the right. Hydrogen is at the top left. So nitrogen is more electronegative. And so we're going to draw arrows at every bond towards the one that is more electronegative, because that's the way the electrons are going. We put a little plus sign at the tail to remind us that electrons are leaving this area, leaving it slightly positive. We take a look at all 4 sides. Down at the bottom, we have the plus tail, and the plus tail at all 3 of the hydrogens. But up at the top, all of the electrons are moving this way, plus we have the non-bonding pair of electrons up here. So all the electrons are clustering around the nitrogen. That makes the top of this nitrogen slightly negative, and down here by the hydrogens slightly positive. Because we have a slight negative here and a slight positive here, we say that this molecule is polar. Okay. Let's take a look at H2O, or water. Okay, so our Lewis structure here, we have oxygen. That's not a good color. Let me switch that here. Oxygen, that's better. Okay, and it has 6 valence electrons. Hydrogen each has 1, and we have 2 of them here. So we're going to put 1 hydrogen here and 1 hydrogen here. Okay. we're going to show our two pairs of non-bonding electrons this way. Okay, now remembering that these non-bonding pair of electrons are going to take up a lot of space. They're going to move to the top and push everybody else down out of their way. So we're going to start here again with our oxygen. We're going to show one non-bonding pair over here, one non-bonding pair over here. Remember to show that they take up space. We draw in our little bubbles around them, and they're going to push these two hydrogens down and out of their way. One is going to come to the left, and one is going to go to the right, both within the same plane. So none are coming towards us or moving away because they have space on either side and there's nobody in the middle to push them out of the way. Okay, so then the name for this VSEPR structure is bent because it's been taken from here and these have just been like moved down and bent partially over there. Okay, all right. For polarity, we redraw our VSEPR structure. Then we look at our periodic table and to see which element is more electronegative. Oxygen is farther to the right, so it's more electronegative. We draw our arrows along the bonds towards the one that is more electronegative, putting a little plus sign towards the tail to remind us that the electrons are moving towards the one that's more electronegative, leaving this side slightly positive. We look at all sides of our compound here, and we see that at the bottom, left and right, we have these little plus tails because the electrons are leaving the hydrogen. At the top here, we have two non-bonding pairs, and all of the electrons here are being shared closer and pulled towards the oxygen. Because of this, the top has a slightly negative charge and the bottom has a slightly positive charge. That tells us that this is polar. One more. All right, CO2. So we have carbon. It has 4 valence electrons. Oxygen has 6. So we have our 2 oxygens here. Okay, so we're going to double bond here with oxygen. We're going to double bond here with oxygen. Now carbon has 8, oxygen has 8. Everybody's happy. No non-bonding pairs on the carbon. Okay, so that's here 1, 2, 3, 4, 5, 6, 7, 8, right? That also leaves us then with a non-bonding pair on oxygen. Okay, all right. Now we are going to look here. There's no non-bonding pairs on the central atom. There's no atom up at the top. There's no atom down at the bottom. Remember, the whole goal here is for the electrons to be spread out as far as possible. And if we look at this, they already are. Okay, so everybody's as far away from each other as possible, 180 degrees away. So our VSEPR structure here is exactly the same as our Lewis structure. And then this is referred to as linear. All right, and then for polarity, we look at carbon and we look at oxygen on the periodic table. Carbon is slightly left, oxygen is further right, so that tells us that oxygen is more electronegative, so we point our arrow across the bond towards the one that is more electronegative. Then we look here and say, okay, let's compare both sides of the molecule. The electrons are being, some electrons are being pulled this way towards this oxygen, some electrons are being pulled this way towards this oxygen. Both sides are slightly negative, so the sides are the same, which means non-polar. Sorry guys, I forgot to add in our second pair of non-bonding electrons here. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then carbon has 1, 2, 3, 4, 5, 6, 7, 8. Okay. Alright. And that is how you draw VSEPR structures and predict the shape in 3D that a molecule would take, and how you can tell if a molecule is polar or non-polar.